How the cutting tool leads into and out of a toolpath segment, as well as the links between them, is crucial for tool safety and surface finish quality. Many times, you need to make changes to these after a toolpath is calculated or may want to explore different options. This typically requires a complete recalculation of the toolpath, increasing the time needed to program a component, leading to longer manufacturing times and inefficiencies. Autodesk Fusion's leads and links modification gives you the flexibility to update either all leads and links or a manual selection of individual ones without the need to perform a complete calculation, allowing you to start machining faster. Let's look at some examples of how the leads and links modification can be used to make changes to a toolpath. In this example, we are machining a section of this mold core. Looking closer, we can see that the leads have not been fully applied to the toolpath as it cuts down to another surface, which does not leave enough room for them. The leads and links modification can help by allowing us to quickly make changes to the toolpath. There are 4 tabs. The first one determines the selection. We can choose to select all moves, individual moves, combined moves, or only the plunge moves. A filter can also be applied to help with the selection. In this case, we will choose to select all moves as we want to change all of the leads. The next 3 tabs define what we would like to change, starting with heights. The clearance geometry can be changed to either a plane, cylinder, or a sphere, and its direction defined. Additionally, the clearance and retract heights values can be set. How the tool transitions between toolpath segments can be modified in the Linking tab. In the last tab, options for different types of leads and their parameters can be found, along with lead extensions and a few other key options. In this situation, we are going to apply the Trim Segments option, which will automatically trim the toolpath segment, allowing room for the lead to be applied. We are also going to increase the surface normal arc size to be 1 mm. After selecting OK, the leads will be recalculated to apply the changes, but the actual toolpath will not, making this change drastically quicker. We can see now the radius size has changed and is fully applied to all segments due to the toolpath being trimmed for the needed space. Let's make a few more additional changes. First, we would like the leads to be a little longer for the entry and exit. Using the modification tool, we can add an extension with the choice of an extended move and set the distance to be 3 mm. Next, the rapid clearance moves are inefficient, retracting back to a plane above the part. From the modifications, let's choose a cylinder plane, define the direction to be the setup x-axis, and choose the center of the geometry to be its origin. We can then set the plane clearance distance. Additionally, in the Links tab, we will set the retraction to be minimum. The rapids are now more efficient, moving over the part in a cylindrical motion. One last change, the first move in and last retraction are using the cylinder plane. Let's change them so the tool approaches and escapes from the z-axis. From the modifications, we will select individual moves and select these 2 moves so that we only apply a change to them. From the Heights tab, we can select a plane from the z-axis. We can now see that only these 2 moves have been changed to create the desired result. These modifications are added to the toolpath timeline and are associative to it, meaning that if a toolpath is recalculated, that they are applied to the new result. This also allows for you to easily make changes such as deleting a modification or editing a parameter in one. For example, if we would like to change the distance of the extension, we can select to edit the modification and change the linear distance from 3 mm to 1. The toolpath is then updated to reflect the change. Let's review another use case example. Here we are machining an undercut in 5-axis, but if we simulate the toolpath, there is an issue where the lead out has not moved the tool to a position where it can retract safely. We could change the lead settings in the toolpath, but it will change all of the leads and may require multiple attempts to find the correct parameters, each requiring a toolpath recalculation costing considerable time. Only the last lead out needs to be adjusted, so let's use the modification tool to make a change to correct this issue. We will choose to select an individual move and pick the final lead out. In the Leads tab, we will select the Trim Segments option and use a surface normal arc with a radius of 10 mm. The resulting change to the toolpath trims the segment back to allow for a larger radius, moving the tool into a safe position for retraction, which can be confirmed by a toolpath simulation. The advanced functionality of Leads and Links modification in Fusion not only significantly decreases programming time for toolpath adjustments by allowing changes to be made in clearance geometry, clearance and retract heights, start and end positions, rapid links, transitions, and leads without the need for a complete toolpath recalculation. It can also help to resolve issues that might be challenging or impossible to address solely by modifying strategy parameters. These modification tools aid in decreasing your programming time, allowing you to get machining faster.